for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on equilibrium expression and equilibrium constant. Last time we were learning together, we discussed the law of mass action. It states that the combining power of two reactants, A and B, depends upon their nature as well as their active concentration. It also states that the rate at which these two reactants combine is directly proportional to the product of their concentration terms, each raised to the power of the respective coefficient in the balanced chemical reaction. We also defined the equilibrium constant as a way to determine whether a reaction has reached equilibrium, and we wrote the equilibrium constant expression for a chemical reaction that involves concentration. In the meantime, you have been learning to calculate values for equilibrium constant involving concentration and discussing the relationship between K subscript C and K subscript EQ. During today's lesson, we are going to discuss the relationship between K subscript C and K subscript P. We will also distinguish between homogeneous and heterogeneous equilibrium reactions. Let us begin. Homogeneous equilibrium means that all the reactants and the products are present in the same phase or physical state. Salt and water are a good example of heterogeneous equilibrium. When they are mixed together, the concentration of the salt becomes constant with time. For homogeneous equations, there are rules that must be followed for writing the expression for equilibrium constant. The concentration of all substances formed as products are written in the numerator. The concentration of all the reactants are written in the denominator. Also, each concentration term is raised to the power by its respective coefficient as written in the balanced chemical reactions. For general reactions, we use this expression. For Kc, which is the equilibrium constant, we use this expression. The unit of Kc of a reaction depends upon the number of moles of the reactants and products involved in the reaction. A mole is a unit of measurement for the amount of substance or species which would be the reactants and products in this case. Therefore, for a general reaction, the unit of Kc will be this. Kc is the ratio of the product's concentration over the reactant's concentration. When all the reactants and the products are in their gaseous state, their concentrations can be written in terms of partial pressures. Partial pressure is the pressure a gas would have if it alone occupied the volume. In such cases, the equilibrium constant is denoted by Kp. This is the expression for Kp. Kp is the ratio of the product's partial pressures over the reactant's partial pressures, each raised to the power of its respective coefficient in the balanced equation. The equilibrium that involves reactants and products in different phases is called heterogeneous equilibrium. The reactants and the products are present in more than one physical state. Thermal decomposition of calcium carbonate is a great example of a heterogeneous reaction. Here are two more examples of heterogeneous reaction. Just as there are rules for writing the expression for equilibrium constant for homogeneous reactions, there are rules for heterogeneous reactions. The concentration terms of products are written in the numerator, and the concentration terms of reactants are written in the denominator. These are raised to the power of their respective coefficient in the balanced chemical equation. While writing the expression for Kc, the molarities of gaseous reactants and products and species present in the solution are written. The concentration terms solid and pure liquid do not appear in the expression as they are taken to be unity. Also, while writing the expression for Kp, partial pressures of only the gaseous reactants and products are written in the equilibrium constant expression. Students, let us do an activity. In a moment, you will be given a heterogeneous reaction. Write the equilibrium constant expression for this reaction.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to write the equilibrium constant expression for that reaction? If you came up with the answer Kp equals P subscript CO2, you are correct. Students, let us do another activity. To make sure you remember the difference between homogeneous and heterogeneous equilibrium reactions, please define each of these.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. You were right to say that heterogeneous equilibrium reactions are reactions that involve reactants and products in different phases. You were also correct to say that homogeneous equilibrium reactions are reactions in which the reactants and products are present in the same phase or physical state. In today's lesson, we distinguished between homogeneous and heterogeneous equilibrium reactions. We also discussed the difference between Kc and Kp. Kc is the ratio of products concentration over reactants concentration, while Kp is the ratio of products partial pressures and reactants partial pressures. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.